In the world of artificial intelligence, data is not just important, it is foundational. Without data, AI systems cannot learn, adapt, or improve. From the earliest days of machine learning to the most advanced deep learning models today, the role of data remains central to every stage of development. Imagine trying to teach a child to recognize a cat without ever showing them one. You might describe its shape, its fur, or the sound it makes, but until the child sees multiple examples of cats in different contexts, they cannot fully grasp the concept. The same is true for AI. An AI model requires a vast number of examples, images, words, sounds, or numbers, to learn patterns, make predictions, and ultimately make sense of the world. The process begins with collecting data. This can come from countless sources: text scraped from the internet, images from open repositories, audio clips, videos, sensor data, and more. The sheer volume is staggering. For example, large language models like GPT-4 are trained on hundreds of billions of words. But more isn't always better. The quality, diversity, and relevance of data play an equally critical role in determining how well an AI system performs. Once data is collected, it must be cleaned and labeled. This step is often the most labor-intensive. Cleaning involves removing errors, duplicates, or irrelevant content. Labeling, on the other hand, involves tagging data with the correct information. For instance, identifying objects in images, marking spam emails, or categorizing sentiments in a sentence. Labeled data is especially vital for supervised learning, where the model learns by example. The next phase is training. During this stage, an AI model consumes the prepared data and adjusts its internal parameters based on the patterns it detects. In essence, it learns from the data by minimizing its mistakes over millions or even billions of iterations. The better the data, the more accurate the model becomes. But the role of data doesn't end there. After training, models must be tested on new, unseen data to evaluate how well they generalize. This testing phase is crucial. If a model performs well only on training data but fails on new inputs, it suffers from overfitting. That's why datasets are often split into training, validation, and test sets. Moreover, as AI models are deployed in the real world, they continue to interact with new data. This feedback loop, where models learn from real-world performance and adapt over time, is called continual or online learning. It allows AI to stay relevant, improving as environments evolve. However, with great data comes great responsibility. One of the major challenges in AI training is bias in data. If the data reflects historical inequalities or skewed representations, the AI model will inevitably learn and reproduce those biases. That's why ethical data collection and auditing are becoming essential practices in modern AI development. Developers must actively seek diverse, balanced datasets and monitor model outputs for unintended consequences. Another challenge is data privacy. With AI systems often trained on personal or sensitive information, there's a growing need for privacy-preserving techniques such as differential privacy or federated learning. These allow models to learn from data without directly accessing individual records, preserving user confidentiality. In the end, data is the lifeblood of artificial intelligence. It shapes how machines see the world, how they respond, and how they evolve. Without data, there is no AI. And with poor data, there is poor AI. That's why the future of AI is deeply tied to how we collect, curate, and care for our data. Data also plays a critical role in shaping the type of intelligence a model develops. Consider this. If you feed a model only financial data, it becomes an expert in economics. If you train it solely on medical journals, it becomes a digital doctor. The data determines the domain, and the domain determines the scope of intelligence. This is why multidisciplinary training, using data from a wide variety of sources, is so valuable. It enables models to perform better in general-purpose tasks and show flexibility across multiple contexts. For instance, modern AI assistants like ChatGPT or Gemini can answer a wide range of questions, from historical facts to programming solutions, because they were trained on diverse datasets covering books, encyclopedias, websites, and forums. However, this also increases the complexity of data governance. The broader the scope of training data, the more difficult it becomes to ensure accuracy, relevance, and neutrality. There's also the question of data scaling. In recent years, the prevailing trend has been the more data, the better the performance. This scaling hypothesis has proven true to a point. As model size and dataset size increase, performance on benchmarks tends to improve. But it's not a linear relationship. Eventually, the returns diminish, and more data simply leads to redundancy or computational waste. This is where data curation comes into play. Rather than just increasing the quantity of data, researchers are focusing on improving its quality. Techniques like data filtering, deduplication, and relevance scoring help ensure that only the most useful and informative examples are used in training. Think of it as training a world-class chef, not by giving them every ingredient in the supermarket, but by selecting only the freshest, most essential components. Another emerging concept is synthetic data, data that is artificially generated rather than collected from the real world. This is especially useful in domains where real data is scarce, expensive, or sensitive. For example, self-driving car simulations generate virtual street environments to train AI safely and efficiently. Likewise, generative models can create realistic medical images for training diagnostic systems without compromising patient privacy, but synthetic data is only as good as the models and assumptions behind it. If the synthetic generator has flaws, those errors will propagate into the trained AI. Therefore, real-world validation remains necessary. A blend of authentic and synthetic data often yields the best results, balancing diversity, availability, and ethics. One cannot overlook the role of annotation tools and human-in-the-loop systems in the data pipeline. Despite advances in automation, many tasks still require human judgment, especially in nuanced areas like emotion detection, ethical categorization, or intent classification. Humans help set the standard by which machines learn, and this human touch remains a vital part of building ethical, aligned AI systems. As AI continues to expand into more critical areas, healthcare, law, education, defense, the importance of trustworthy data will only grow. It's not just about training smarter machines. It's about ensuring that those machines behave in ways that align with human values, social fairness, and contextual understanding. Ultimately, the saying, "garbage in, garbage out," has never been more relevant. The intelligence of a system is only as good as the data it was trained on. That's why the future of artificial intelligence depends not just on algorithms or hardware, but on our wisdom in choosing, managing and respecting the data that fuels it. This brings us to the evolving role of data stewardship. As organizations and researchers build increasingly powerful AI systems, they must adopt practices that prioritize transparency and accountability. Where did the data come from? Who owns it? Was consent given? Is it representative of all populations? Initiatives like model cards, data sheets for datasets, and documentation standards are steps in this direction. They aim to make the data pipeline visible, not just to engineers, but to regulators, ethicists, and the public. After all, if AI systems will influence hiring, healthcare, policing, and policy, then the people affected deserve to understand how those systems were trained. Data is no longer just a technical resource. It is a governance issue. It requires interdisciplinary thinking that includes not just computer scientists, but sociologists, ethicists, and lawmakers. Because data, at its core, is a record of human behavior. It reflects our conversations, decisions, biases, and beliefs. And AI learns from all of it. The future will likely involve more user agency over data. People will want to know if their data is being used to train models. They will ask for ways to opt out, to control their contributions, or even to earn compensation when their data adds value to an AI system. These are important questions, and the AI community must be ready to answer them. In conclusion, the role of data in AI training is more than foundational. It is transformative. It shapes not just what AI knows, but how AI behaves. As we stand at the frontier of ever more powerful models, we must remember the most intelligent machine is still a reflection of the data it sees. And the way we collect, protect, and honor that data will determine not only the future of AI, but the future of trust in technology itself. As we move forward, let us not forget that behind every dataset are real people, real lives, and real consequences. Building ethical, powerful AI begins with honoring the data and the humanity it represents.